Hey guys, welcome back to the programming interview series where we'll be breaking down interview programming questions step by step. For this series, we'll be working on a website called Codility, which has lots of free practice questions to choose from. We'll be solving our solution today using Java. Today, we're going to be doing Lesson 4, Question 1, Frog River 1. So for this question, I'm just going to read out the problem and we'll go through the steps that we'll be following. So a small frog wants to get to the other side of a river. The frog is initially located on one bank of the river at position 0 and wants to get to the opposite bank at position x plus 1. Leaves fall from a tree onto the surface of the river. You are given an array A consisting of n integers representing the fallen leaves. A at time k represents the position where one leaf falls at time k, measured in seconds. The goal is to find the earliest time when the frog can jump to the other side of the river. The frog can only cross when one leaf appears at every position across the river from 1 to x. That is, we want to find the earliest moment when all the positions from 1 to x are covered by leaves. You may assume that the speed of the current in the river is negligibly small, i.e. the leaves do not change their positions once they fall in the river. So for example, you are given an integer x equals 5 and an array A such that A at time 0 equals 1. So at time 0, a leaf falls in position 1. We have A at time 1 equals 3, A at time 2 equals 1, A at 3 equals 4, 2, 3, 5, and 4. So in this question, we have to find out at what time the frog can fully cross the river, so when all the leaves have fallen. So if we go to our example, we are looking for when all the leaves have fallen across the river, so all 5 leaves, and then the frog would be able to jump across. So he starts at position 0, x equals 5, meaning that there's 5 leaves that fall onto the river. So let's begin. So at time 0, a leaf falls in position 1 on the river. Then as we continue, at time 1, a leaf will fall on position 3. At time 2, another leaf falls on position 1, but there's already a leaf in that spot, so it doesn't really matter. We can ignore that one. At time 3, another leaf falls in position 4. At time 4, a leaf falls in position 2. At time 5, a leaf falls in position 3. And then finally at time 6, a leaf falls in position 5. So as we can see here at time 6, there's a leaf in every position. Our array does go to 7, but the earliest that our frog can cross is actually at position 6 when there's a leaf in all 5 positions. So our frog can cross the river and go to the other side. Okay, so we will begin coding our solution to this problem. We have our class frog river 1, and we're going to start by creating our main function. So we have public static int solution using integer x as a parameter and an integer array A as a parameter. Next, we're going to create a variable called second to jump. And this is going to be an integer, and it's going to be our variable that tells us what second the frog is allowed to jump in. Okay, and then next, we're going to create a hash set. And we're going to call the set fallen leaf set, and it's going to contain only integers. So the reason we're creating a set is because a set in JavaScript only contains unique numbers. So we're going to want to make use of this functionality by inserting all the unique numbers that appear while we're going through our array. So for example, if leaf 1 falls, we'll add it to our set. But then if leaf 1 falls again, it'll already be in our set, so we won't need to add it a second time. Because remember, the goal here is to find out when all the leaves have fallen, and then the frog can cross. Next, we're going to create our main for loop for this function. So we're going to have a for loop from integer k equals 0. K is less than a dot length. And then we're going to do k++ to increment by 1. Okay, and then we're going to have a new variable called fallen leaf. So integer fallen leaf is equal to the array a at time k. So this basically tells us which leaf falls at time k. And then, so now since we know which leaf just fell, we want to add it to our set of fallen leaves. So fallen leaf set dot add fallen leaf. And then to solve the problem at hand is we're going to look at the size of our set. So if fallen leaf set dot size is equal to x, since x is the number of leaves that the frog has to jump across. So if the size is equal to x, that means that all the leaves have fallen. So if all the leaves have fallen, then we return k, which is the time at which the last leaf fell. And then outside of the for loop, if we get there, we return -1, because if we get to this point, it means that it was impossible for the frog to fall. So keep in mind that when a return statement appears in Java, it stops the execution of the function completely. So if we hit this return k line, then the whole function stops. And so we'll never be able to get to the return -1 line. Now that our main function is completed, we're going to just test it out here in Eclipse before we test it out on the website. So let's create an integer array a is equal to a new int array, and we're going to have the values 1, 3, 1, 4, 2, 3, 5, and 4. Next, we're going to try out our function. So we do a system.out.println solution. X is 5, and then using our array a. Then if we run the script, we're going to see that our answer is 6. And this is the answer that matches up with the example in the question. So from here, we can go and copy this to the website and see what we get. So here we are on the Codility website on the question. So let's just go and submit our answer. So what we'll do is we'll just copy in our code into the solution method here. All of this. Okay, this has to change to a small x, and then we're also going to want to import the collections that we used like this. So we can run a test here to see if it still works. Perfect. So it worked in this environment. So let's submit the task and we'll see what we get. Session has ended. Okay, so it's running our test now. There we go. We got 100%. So we have 100% correctness and 100% performance. And we see that our time complexity is ON. Awesome. Well, thank you guys for watching this tutorial. As always, leave a like, leave a comment down below if you enjoyed the video. And I'll see you guys next time. Thanks.